All right, so let's look at solving quadratics with factoring and zero property. So when you factor, remember you end up with something like this, where you have like x plus 2 and x, I don't know, minus 4. Setting these equal to 0 will give you the value that you need. So we would have x equals -2, and then we would have x equals 4. So this is kind of a brief summary of what we're going to be doing today. So here's an example. This is what we're doing. So what I was just saying is we're going to set them equal to 0 so that we can solve. So here's the start. All right, so in this case, we have our two binomials already set up for us. So we would have 4t plus 1 equals 0, and then t minus 2 equals 0. So then we would solve for t on both of them. So t equals -1/4. So we would have t equals -1/4 and t equals 2. Those would be the two solutions. So if you were to graph them, they would be passing the graph at -1/4 and at 2. All right, so here we have x squared plus 8x plus 15. We are going to factor it ourselves. So I'm going to start by setting up my binomials. So we would have x and x. Both are positive. And for my x puzzle, we're looking for a product of 15 and a sum of 8. So it looks like we have a +3 and a +5. So this would get us what we need. Now we're going to solve these by setting them equal to 0. This is at 0 property. So I'm going to subtract 3, so x equals -3. And here we have x plus 5 equals 0, so I'm going to subtract 5 on both sides, so x equals -5. So we're looking for A, where x equals -5 and x equals -3. All right, here this one is already factored for us. The 4 hanging out front means nothing at this point. So we're going to have x plus 16 equals 0 and x minus 2 equals 0. So then all we have to do is solve for x in this case. So x equals -16 and x equals 2. So our solutions would be -16 and 2. And usually you'll see it like in brackets or something like that. And they're usually listed in order from least to greatest. All right, so now we have 4x squared minus 21x equals 18. I need to rewrite this in that standard form, ax squared plus bx plus c. So I need to subtract 18 to move it to the other side. So now I have everything I need. I'm going to start by drawing my box and my x puzzle. So -18 times 4 would be -72. And I need a -21 for my sum. So I'm going to put in my first term, my last term. So I need, let's see, I need factors of -72 to get a sum of 21. So 1 and 72, well, actually, let's see here. We're going to have, it looks like one of each, because I have a negative product. 1 and 72 isn't going to work. 2 and 36, nope. 3 and 24 is where it's at. So one of them needs to be positive, one needs to be negative. I need the sum to be negative, so it would be a -24 and a +3. So I'm going to put a +3x here and a -24x here. So for the first term, I guess let's start here. So I can factor out a 4x, and looks like a +3 here is going to be what I need. For the next column, this is going to be an x, and let's see, 6 times 4 is 24, and 6 times 3 is 18, so it'd be a -6. So we would have 4x plus 3 and x minus 6. So in order to solve, we're going to set these guys equal to 0. So we have 4x plus 3 equals 0, x minus 6 equals 0. So now we just have a simple, so x equals -3/4 here, adding 6, x equals 6 here. So those are our two binomials solved for our solutions. So then if we're going to list our solutions in brackets, it would be -3/4, 6. And again, if you were to graph it, you should see that they pass through the x-axis at those 2 points.